start by saying what's new. What are some of the things to be aware of when doing this upgrade? If you're coming from 09, then there's going to be a variety of new things. There's a new storage engine. There's a new continuous query syntax, which allows for finer control over the CQ execution. And there are some new API endpoints as well. If you're coming from 08 to 013, there's even more changes. There's a different schema, a new API. Joins are now no longer part of the syntax, but they aren't necessarily required because all series are joined under a measurement by default. Shard spaces and that concept have now become retention policies. It's a very similar thing. The query syntax is completely updated to deal with the fact that the schema has been changed, and now all administrative duties are carried out through queries as opposed to using the admin UI interface. So there will be quite a few things to get used to. We'll give you, see if I can, for some reason I'm unable to advance my slide here. Hold on just a moment. Okay. So to briefly touch on some of the things that you might want to research before you do this upgrade. One thing to mention up front is that clustering in 013 is part of the closed source product. It is no longer part of the open source product, and it is not backwards compatible with the other clustering solutions. So right now there is no way to take an 09, 10, or 11 cluster and upgrade it to InfluxDB 13, short of essentially exporting the data and re-importing it. The CQ syntax and configuration are different. So definitely want to take a look at how your CQs are built and make sure that you're ready to reissue them for 0.13. And in 0.13, the query endpoint now requires you to post queries that have potential to take destructive action. So select and show queries, which are purely read operations, you can still use the get protocol. But if you're going to do something that like a drop, alter, create, that actually has an impact on the database, then you need to use post the post method. There are some links on here to documents that will be useful for those of you who are looking at a migration. We have some technical papers, including a technical paper that is largely based on this course. We have on the 0.13 docs, there's an upgrading page that describes how to upgrade. And then we also have the differences between 0.12 and 0.13. and the differences between 0.13 and the previous versions. So you can look at those as far back as you need to understand what to prepare for when upgrading. So why upgrade? What are the compelling reasons? The first and greatest compelling reason to upgrade from a prior version to 0.13 is the TSM storage engine. If you're on 0.8 or 0.9, you're currently using an older version of the storage engine. It's a little bit different for those two. But in 0.10, we introduced the TSM storage engine, and it has become the only supported storage engine in the database at this point. It has much greater throughput with a much smaller footprint. We are seeing a number of people going from 09 into 013 who are getting 95, 98, 99% compression compared to their previous data sizes. And whereas with 0.9, one of our benchmark machines would run about 350,000 points per second, with 0.13, we're up to about 1.2 million values per second running in. So it's a substantially faster throughput. With 0.11, we introduced a new query engine, which is more performant than the old one, has many fewer corner case bugs, and is well positioned to add new features and functions, which have been a regular part of every release since. As well, the continuous query syntax has been updated. So in 0.9 and I believe in 0.10, CQs were scheduled in it globally. So you could create multiple continuous queries, but they would execute with a frequency and over a lookback interval that was the same for every CQ, essentially. Now you can control that per query, and it is explicitly something that you choose when creating them. Another compelling reason for many people to upgrade is telegraph and capacitor. So telegraph is the collector in the tick stack. It is the thing that you can use to collect your metrics from any of the 50 different plugins that are supported, or you can take many of those plugins that support generic operations like exec, or there's a log file parsing on the way. So Telegraph relies on the latest features in InfluxDB. If you are not running InfluxDB 0.13, it is not recommended that you run Telegraph 0.13. And that might be the one that has the input plugins or the output plugins that you need. Capacitor is the ETL monitoring and alerting tool that we have in the tick stack. And as well, Capacitor ODOT13 is compatible with InfluxDB ODOT13, not necessarily with prior versions. And Telegraph and Capacitor are adding new functionality very rapidly. So being on the latest release is definitely an advantage. And then finally, 0.8 is absolutely end of life. There will be no more further development on it. And 0.9 is essentially deprecated at this point. There has not been a code release on 0.9 for quite some time. It is still supported, but it is definitely recommended that, especially as we look towards 1.0 this summer, that you begin moving towards an easier upgrade path. So a little bit more about TSM, the time structured merge tree. Again, it's a purpose-built storage engine. So it is not another database that has been sort of co-opted to put underneath the InfluxDB code, as was the case with 0.8 and 0.9. It was built specifically for this use case. It has compression built in by design, so it supports multiple different compression levels based on the age of the data and the coldness of the shards, and it does not leave empty space like many B+ trees would require in order to have out-of-sync writes later. And one of the best things about the TSM engine is that when you query points, if you have a point that might have, say, 10 fields on it, so 10 metric values that you've recorded, not metadata, but actual measurements, then you only want to query, say, 2 of those. We only need to read 2 of them off disk. You don't have to read the entire point, which was the case with earlier engines. So what tools exist for the migration? If you're coming from InfluxDB 08, then the most important tool that you're going to have is the export endpoint, which is part of 0.8.9, which was a release in the 0.8 line explicitly for getting this export tool in there. And then also the import tool, which is part of the command line interface that ships with every InfluxDB 0.9 plus. If you're coming from 0.9, there's a slightly different path, and you're going to end up using the TSM Conversion tool. This is a tool that will take the existing B1 and BZ1 shards that were created in 0.9 and convert them to the TSM engine so that they can be read by future versions. And if you're coming from 0.9, 0.10, or 0.11, you're also going to need to export and re-import the Metastore. The change with the clustering between 0.11 and 0.12, where clustering was put into the closed source product, we removed a lot of the clustering logic from the open source single node database, which greatly simplified its operation and increased performance. But it does mean that the Metastore in 0.9 through 0.11 is not compatible. And the way in which we migrate it forward is simply to export it and re-import it, which is a very quick operation. And we'll see some examples in a minute. So let's take, to start with, an example migration. This example migration, we're going to say that downtime is irrelevant. We have ourselves in a situation where we can plan to have downtime, and we don't need to be overly concerned with how long we take InfluxDB offline for the upgrade. We are going to be converting from a 0.9 database. And again, it's not clustered. So if you're trying to upgrade a cluster, please reach out to contact@influxdb.com so that we can get you the support that you need. But we do not recommend that you attempt to upgrade a cluster on your own. So what are the steps going to be in upgrading this 0.9 server to the 0.13? We're going to stop the traffic to 0.9 because we said that downtime was okay. We're going to then install InfluxDB ODOT11, which is an intermediary point on the way to ODOT13. We'll get into why we need to do that in a minute. We're going to convert the shards to TSM. So we're going to take all those 09 shards and we're going to turn them into the new engine. We're going to then export the Metastore from the existing ODOT11 instance. We'll then install InfluxDB ODOT13, and then we'll re-import the Metastore. And so that's how we're going to convert the Metastore, is we export it from the prior version and import it into the latest version. And then once we've done that, so we've converted all the shards to TSM, and we've brought the Metastore forward to the current version, then we simply resume traffic to InfluxDB. So let's take a look at each of these steps in a little more detail. So stop the traffic to InfluxDB 0.9 is our first step. We recommend that you watch the logs, tail the logs to make sure that writes have stopped. And then once the incoming writes have stopped and you're seeing no more post requests coming in from your clients, then restart the database. On restart, InfluxDB has to flush the entire write ahead log, which is definitely something we want to do. We want to get all the points into the permanent storage area of the disk. We don't want them to be in the wall, which is essentially a scratch pad. Points in the wall may or may not survive a migration. So if you restart InfluxDB, by the time the HTTP listeners are back up and running, that means by definition your wall is empty. Or has been emptied. And since we stopped all the clients from writing, we know there's no more new points coming in. So once we have a completely still database, then we can go ahead and grab O.11. So you want to get O.11.1 is the correct version to grab. And there are some URLs to download that at the link given in here. So download the package. We can stop InfluxDB at any time here. And then we're going to install InfluxDB O.11 on top of O.9. The instructions for that will be on the installation page for O.11 and specific to whatever system you're using, although it's relatively generic. Then once we've installed O.11, we're going to merge the configuration files. And this is a recommended step anytime you do any upgrade, even if it's just a simple point upgrade from a minor version to the next minor version. What we recommend is that you take the configuration file that ships with the newest version and diff that with your existing configuration file to migrate forward the settings that you have that you want to preserve, but also make sure that you are collecting and using the default settings that are appearing in the newest version, and also expiring out the settings that no longer have any relevance to the new version. And there's some information on how to do this at the link given there. Now, we don't want to start InfluxDB O.11 at this point. In fact, it won't start because you still have B1 and BZ1 shards on disk, and InfluxDB O.11 refuses to launch if it detects those. So what we're going to do is we're going to convert all those shards from the B1, the Bolt DB, either compressed or non, so B1 or BZ1. We're going to convert those to the TSM format. Because we have the system is not under load and the InfluxDB process is not running, we don't need to worry about what we do to our CPU and our RAM. We can go ahead and use it all if we want it. So we're going to convert the shards in parallel. And this is not a particularly risky operation, so we're not going to create backups of the original shards. But if you wanted to, you certainly can. And so we see the command here below. The -parallel switch is telling Influx TSM, use as many cores as you want to do this. You have the whole machine, it's yours. And then the no backup flag simply says don't create a backup. If instead you had the -backup flag, you would provide a path where it would write all of a copy of all the existing B1 and BZ1 shards, just in case something went wrong with the conversion. And then the final thing we give here is the path to the data. So most installations, that would be varlib InfluxDB data. If you've changed that, obviously you'll need to provide the correct path. Converting to TSM is a relatively quick operation, and it will give output as it's going, and it will also then at the end give you the output of how many shards were converted and how much space was recovered by doing so. So it will give you a compression ratio at the end, or a compression percentage. Now that we have all of our shards into TSM and we have O.11 installed, we still want to get to O.13, and that means we still need to deal with the Metastore incompatibility. So we're going to use the InfluxD binary, which is the InfluxDB daemon, but we're not going to call it to launch a daemon. We're just going to call it in a standalone mode with the backup switch. And what that will do is say, please create a backup, InfluxDB. We are going to start InfluxDB O.11 first. So we're going to get the daemon up and running. Then we're going to call the InfluxD binary with the backup flag, and we're going to give it a path where we want the backup to go. There are some specific directions at the URL given here on how to do this Metastore only backup and restore. The InfluxD backup switch by default only does the Metastore. You have to supply the explicit database and retention policy that you want it to back up if you want more to back up actual data. And there are very detailed instructions on how to do so in the documentation. We won't cover that here. Backups are outside the scope of this webinar. But we use this command below to back up the Metastore to temp. And now we're ready to go ahead and bring down InfluxDB O.13. So downloaded the latest package. It's O.13.0 as of today. I believe .1 is probably due fairly soon with some minor bug fixes. We're going to install O.13 on top of O.11. You can do this while O.11 is running. That's fine. The daemon that is up and running has created its own environment. It's going to be healthy. It's fine while you install another binary on top of it. And then again, we're going to need to merge the configuration files. There are some new switches and settings in ODOT 13 that don't exist in ODOT 11. So make sure that you migrate the correct things forward and get the configuration ready. Don't restart InfluxDB 013 at this point, though, because first we have to import the Metastore. Now that we have an ODOT 13 binary on the system, we can call that binary, which is now the InfluxDB binary, and we will restore the meta directory that we backed up. So we're going to give it the restore switch, and we're going to tell it that the meta directory we wish to restore to is in barlib influxdb meta, and we're going to then give it the path to where we made our previous backup. And what this will do is it will restore the Metastore from the ODOT 11 version, or the ODOT 9 version really, and inject that into ODOT 13, and it will come in the format that ODOT 13 expects and can read. So now that we've converted our TSM shards and we have converted our Metastore, we have ODOT 13 installed. We're ready to start it. So essentially at this point, you restart the process and ODOT 13 will come up. We recommend watching the logs just to make sure everything is okay. There are a number of potential things that could get a little bit that could require some attention after migration. It's fairly impossible for us to exhaustively list them all, and it would require this webinar to be about 6 hours long. So, everybody's environment is different. The important thing is to watch the logs and make sure that everything seems okay. And once things are okay, and we expect that they will be, then resume your read and query traffic. And again, watch to make sure that everything is all right. Down here on the bottom, we've given a little URL for some recommendations on how to move forward from ODOT 10 or ODOT 11, which is a good thing to read before you're getting into ODOT 13. So example migration 2. We're going to move into this one, and we're going to talk. This is going to be a much more involved migration because we're going to say downtime is unacceptable. Now, there is no such thing as a zero downtime upgrade from ODOT 9 to ODOT 13, primarily because of the Metastore issue. We have to export it from one process and import it into the other, but we cannot launch the ODOT 13 binary until we have imported the Metastore. But we need the ODOT 13 binary to import the Metastore. So there's a bit of a spot there where we need to have the system down while we import the Metastore. The ODOT 11 binary, if it were still up and running, would not understand the ODOT 13 Metastore, and the ODOT 13 binary will not launch with the ODOT 11 Metastore in place. However, that is the only downtime that is absolutely required. We are converting again from an 09 instance. The third example that we're going to do after this will be an 08 instance for those of you who are waiting for that. And this is not going to be a cluster. We don't recommend trying to do that. And if you are going to do that, please contact us. So what are the steps for this? So the first one, and this may be a little bit of a surprise, is we're going to install InfluxDB 0.10 instead of 0.11. We'll get into that in a little bit. And this is going to look fairly familiar. We're going to convert shards to TSM, but this time, because we aren't bringing this process down, we can't convert every shard at once. There are some shards that are currently receiving writes, and there is no sane way to try and update those in place. So we're going to convert the cold shards to TSM. And by cold shards, what we mean are those shards which are no longer receiving writes. So the assumption with InfluxDB, as with most TSDBs, is that you are writing data primarily about now and not about a week ago or a month ago or a year ago. If you are writing data that is significantly older, then defining your cold shards becomes a little bit more of a challenge. But the idea being, let's say I have infinite retention, so I have week-long shards. Once we get to Sunday midnight, last week's shard now rolls over, and I'm writing into a new shard file for this week. I can assume that there will probably be no more writes going into last week's shard by the time we get to, say, 2 or 3 a.m. on Sunday, or whatever your most out-of-date timestamps will be. So we can convert all the cold shards because those we can make a copy and know that they aren't going to change while we're converting the copy. But the hot shards, the current hot shards that are receiving active writes, they're changing potentially every millisecond, every microsecond, so we don't want to do anything with them yet. What we can do is convert all the cold shards, and then we can wait until the current hot shards rotate out and become cold. So there's going to be a period here of anywhere between an hour and a week, depending on your retention policy settings, where we simply have to wait. for the data that's being written in to reach an age such that it becomes a cold shard. And then we can convert those last existing B1 or BZ1 shards into TSM. And then again, we're going to export the Metastore, install O13, import the Metastore. And then the final thing here is to update the query sources. And that's not something that we put on the first migration, but since we talked about zero downtime here, or at least zero downtime as an aspiration, we're going to talk a little bit about some of the things that need to be done before we're ready to do that. So the first step, installing InfluxDB 0.10. Now, why is this not 0.11? The answer is that InfluxDB 0.11, well, with 0.10, the B1 and BZ1 engines were deprecated. But with 0.11, they were flat out removed. So 0.11 will not read or write to a BZ1 or B1 shard, and it won't even launch if it detects them in its directory, because it assumes, hey, you need to run the TSM conversion. That didn't happen. I don't want to launch and have you wonder where all your data went, so I'm just not even going to launch. 0.10, however, the B1 and BZ1 engines were deprecated. What that means is that 0.10 will not create any new B1 or BZ1 shards. Any shards created by 0.10 will be TSM, but it can read and write to B1 and BZ1 shards. So what that means is that while we're in this hybrid period of having half our shards on TSM, the cold ones, or more than half, and then the current hot shards need to remain B1 and BZ1 because that's how they were created. When we run in a hybrid environment like that, 0.10 is really the only instance that will do that. There are later versions of 0.9 that might be okay with that. But again, we're trying to upgrade away from 0.9, so this doesn't help us move forward. And 0.9 does not ship with the TSM conversion tool because TSM was not finalized until after 0.9.6. So we're going to download the 0.10.3 package. It's a little bit hard to find these download links still. I apologize for that. I've given them for the Debian and Red Hat packages here, assuming that people are mostly on 64-bit. If this does not meet your needs, that bare link at the top, the dl.influxdata.com, will give you an XML listing of every binary we've ever built. And you can simply look through there for the 0.10.3 binary that's appropriate for your architecture. So we're going to install 10.3 on top of ODOT9. ODOT9 process is still up and running. We're going to leave it that way. We're going to go ahead and install ODOT13 on top of it. We are not going to restart the process. We're just going to let the O9 daemon go out and continue running while we do a bunch of stuff underneath, essentially, rebuild the foundation underneath it. Again, after installing ODOT10.3, we need to merge the configuration files. And then once the configuration is ready, now we can restart InfluxDB, and now we'll be running the 0.10 version of the binary, which means that it will read and write to the BZ1 shards, but whenever the shard boundary is hit and we roll over to create new shards, it will be creating TSM shards, not B1 or BZ1. So we have started our journey away from TSM. The next thing is going to be converting the cold shards to TSM format. So our recommendation is to make a copy of the cold shards somewhere like, and in this example, we're going to use temp data. So this would be essentially going in and copying all of your shards under data to temp data. That would mean that you're going to grab, the current hot shards as well, but that's fine. We can go ahead and convert a copy of the current hot shards. We just won't overwrite them later because we know they're already out of date. But just to keep the management simpler, I think it's easiest to go ahead and convert all of them. We're going to convert the shards in series instead of in parallel this time, because again, we have an active production process up and running on this box. Another way that you could solve this problem quite easily would be to copy the cold shards from your production server to a staging or another environment somewhere where you have an InfluxDB ODOT10 plus installation that has the Influx TSM binary. So you don't need to convert them on the same box, but in this example, we're just going to assume that that's what we have to do. So we're going to convert the shards in series instead of in parallel. What that means is the Influx TSM binary will only chew up one core, as opposed to taking as many cores as it can find. And since we're on production, we're going to be a little bit paranoid about this. We probably haven't had a chance to back this machine up, or if we have, maybe we haven't backed it up immediately recently. So we're going to go ahead and say, just in case the TSM conversion has a problem, let's make a backup of the B1 and BZ1 shards before we do this. Obviously, that backup will require space. So you're going to need to have at least double what your current data directory is requiring. The TSM conversion tool will write much smaller files than what you have with B1 or BZ1. I don't think we've seen any conversion be less than a 50% reduction. And again, the most common reduction is in the 90%. So we see most people gaining back 90 to 95% of their disk after running the conversion. So here we give the command with the backup flag, and notice we did not give the parallel switch, so it is not running in parallel. And once this is finished and we've received the output and all the TSM shards have been created, the trick is now to replace the existing cold shards with new TSM copies. This is non-trivial because the B1 and BZ1 shards are, well, shards live under a retention policy, live under a database, live under data. So the path would be something like varlib InfluxDB data, and then the name of the database / the name of the retention policy / and then in B1 and BZ1, there's a file with a number, like say 3. So we might have varlib InfluxDB data / mydb / default / 3. And that 3 is an actual file. With TSM, 3 becomes a directory that has files underneath it. So the replace operation isn't as simple as overwriting a file with another file. It's overwriting a file with a directory of the same name. I have found that using the AND concatenator, so rm dash, whatever you want to use, but rm3, the file, and then ampersand, copy recursively the directory 3 from the new TSM shards works relatively well. But again, this is going to be very dependent on your file system, your way of working, how you want to deal with that. There is no way to end up with both the TSM and the BZ or B1 versions because they have a name conflict. You can't obviously have a file and a directory of the same name. So anyway, however you choose to solve that problem is really up to you, but it's relatively low risk as long as they're essentially happening where you're swapping them in and out. The ODOT 10 binary that we're running can happily read from B1 and BZ1, and it can happily read from TSM. So your query should not be affected. So now we assume that we've done that, and the problem is that our hot shards are still B1 and BZ1. They're still being written to. So we have to wait until they age out and go cold, and we can assume that they're no longer updating so that we can make a copy of them and convert them and then overwrite them without missing the points that were written in the interim. With every version prior to ODOT 13, the shard interval is predetermined based on the duration of your retention policy. So if your retention policy is between 0, I think actually 1 hour is the shortest you can have, but between an hour and 2 days, then you have hour-long shards. So you only need to wait an hour for your current hot shard to age out. And then when it does, the shard created for the new hour will be a TSM shard because 0.10 refuses to create B1 or BZ1. If your retention policy duration is between 2 days and 180 days, then you have 1-day shards. And so you'll have to wait a day for your current production data shard to age out and go cold. If your duration, I'm sorry, that should actually say greater than 180 days, my apologies. But if your duration is greater than 180 days, then you have 1-week shards. So anything longer than 6 months, you have week-long shards, and you'll need to wait potentially a week for those to age out. The show shards command will give you the time at which the current hot shards expire. You can simply find the shards that are overlapping now and look to see what their end time is, not the expiration time. Expiration time is when they'll be removed from the system. The end time is when they basically go cold for writes and a new one is created. Again, if you have points arriving out of order, they will still go into old shards potentially, but presumably you have a fairly good control over whether or not there are old points arriving in your system, or if they are arriving, you know how far back they are arriving, and you simply need to wait that much more time for those shards to go cold. So now that the shards are cold, we can convert them. So they're just like when we had come in earlier and done this. We're going to take the newly cold shards, so the shards that just aged out, and we're going to make a copy in temp data. We're going to convert them in series. We're going to store backups if we want to, and then we're going to copy those back on top of the new TSM versions of those shards on top of the existing B1, BZ1 version. So this is really just exactly repeating what we had on step 2, but we're only going to do it against the shards that just recently aged out because those are the last B1 or BZ1 shards we have in the system. And once we've replaced those, now we have an ODOT 10 system that's up and running and quite happy, and it has only TSM files on disk at this point. So now at this point, it's very similar to our previous upgrade after we've done all the TSM conversion. We're going to export the Metastore with InfluxDB. We can do this just fine with ODOT 10. It doesn't matter whether we're using ODOT 10 or ODOT 11 for the Metastore export. And then we're going to install InfluxDB ODOT 13. Again, grab the new package, install it on top of O10, merge the configuration files. Do not yet restart, right? Because we haven't merged the Metastore back in yet. So if we try to relaunch the ODOT 13 process right now, it will not be able to start. We can import the Metastore. And, you know, actually, I think I said earlier that we had to have a downtime when we were doing the Metastore import, but I believe that I recall actually in my testing yesterday that I was able to restore the Metastore against the running instance. And maybe I would recommend that, obviously, if you're going to be doing something like this against a production server, presumably you're practicing on your staging server first. I would advise double checking this step. And it may be something that certain Metastores are compatible and certain Metastores are not. There may be some complexity to your Metastore that requires there to be a little bit of downtime, but ideally not. Once we import the Metastore with the restore command, now we have everything we need. We can, oh, that's right. So sorry, we haven't restarted ODOT 13 yet. We now are ready to relaunch with ODOT 13, but remember, there was a change to the query sources, right? We now need to use post for any create, alter, drop, delete, or a select into command. And so if you have any query sources out there or any dashboards or any administrative tools that you're using, you need to make sure that those are updated for the latest. And you can do some of this work in advance and have it ready to go. Once we've done that, we can restart InfluxDB ODOT 13. It comes back up quite happy. It has the Metastore it expects. It has the TSM files it expects. And we are off to the races. So now the one that we intimated would be coming, the ODOT 8 migration. In this one, we're going to assume downtime is acceptable. And in fact, there is no such thing as a zero downtime upgrade from 0.8 to 0.13. It really just can't be done. There might be some crazy way to do a multiple dual write scenario and have your query, but it just, I think that it would be far more trouble than it's worth. And there's a lot of this work that can be done in advance. So you can prepare a great chunk of the 08 migration and get it done without having to do it all at once in a production environment. We'll get into it as we get into the steps. I think you'll see how it would be easy to do chunks of this so that the downtime that you do have is relatively minimal. And again, this is not a cluster. We're not going to upgrade a cluster. And it does require planning. There are many substantial differences between ODOT 8 and ODOT 13. The most significant one, I believe, is the fact that the schema is very different. ODOT 8 relies on dotted, separated metadata in the measurement name and has only a single field value. In ODOT 13, all the metadata is encoded in key value pairs we call tags. You can have many fields per point, and the entire structure of the database is a little bit different. An ODOT 8 schema will work in ODOT 13, but it will not be performant and it will not have the flexibility that you might want to require. It will definitely lead to some frustration, I think, if you just naively migrate forward with an an 08 schema. However, the tools that we have will do their best to bring you to a modern schema, but not just the schema. There's also a lot of things to learn about the way the API has changed, the way that the tooling and the systems that run around it have changed, and making sure that you're ready to update your infrastructure for the write sources and the query sources so that they are going to be compatible as we move forward. So what are the steps for upgrading 0.8 to 0.13? This will be quite different than what we've seen before because we're actually not going to be migrating the 0.8 server forward. There is no good way to take the existing 0.8 server and turn it into a 0.13 server. Too many things have changed, from the file paths to the libraries to the write protocol, the query language. It's just everything is different. It's going to be a lot of pain to try and do this in place. So instead, what we're going to do is we're going to move all the data from our 08 instance into a new instance that we've set up that's running ODOT 13. So there's no intermediary steps here. We're going to skip straight from 08 to 0.13. No Metastore that we have to worry about, no TSM conversion, because we're not even going to take the 0.8 files and do anything with them. We're just simply going to query the data out and write it back in. So this is an ETL operation, not a convert in place operation. So the first thing we're going to do is stop traffic to InfluxDB. And again, we said downtime is acceptable for this. You could do some of this in a similar manner where we don't stop the traffic, but the export operation is a fairly intense operation. In effect, we are querying the database for every point. So you can imagine that's a significant load. You could spread that load out over time and continue to run a production server, but it feels a little risky, potentially. Again, if you want some help with planning that out, reach out to contact@influxdb.com and we'll see what we can do to support that. But we're going to install InfluxDB 0.8.9 on top of our existing 08 installation. As you may recall from one of our earlier slides, that is the version of ODOT 8 that has the export endpoint, which we will need. We will then use that endpoint to export our data. We will launch InfluxDB ODOT 13 on a new server, so a new instance running the latest code. We will then import the data into that new instance. And then this is where the sort of the really thorny stuff happens, updating the write sources, the query sources, and the CQs in the system so that they're ready for this ODOT 13 world. And then we can resume the traffic into 0.13. And it's steps 6, 7, and 8, which are what make a zero downtime upgrade very difficult for ODOT 8 to ODOT 13. Not impossible again, but I'm going to venture it's probably more work than it's worth. Chances are very good that you can buy yourself 6 hours where the system can be down more easily than you can architect a way to do this with reasonable rollbacks and recoveries should anything go wrong. So first thing we're going to do is stop traffic to 08. Again, monitor the logs to verify that read and write activity has stopped. We just want everything to settle down and be fully flushed and on disk and persisted before we go through the rest of it. And then we're going to install InfluxDB 0.8.9. If you haven't already stopped 08, do that. Install 0.8.9 on top of it. Here's the link for where you can grab that. And run the export tool. So the export endpoint of 0.8. In 0.8, for those who aren't familiar with it, most operations against the API require you to explicitly declare an endpoint, a database, and a shard space. So we've added this export endpoint as a way of exporting from particular shard spaces. It does mean that you're going to repeat the export operation for each unique database and shard space you have in your system. If you have 3 databases, each of which have 6 shard spaces, you're going to need to run 18 versions of this command. That said, that's a fairly large schema for most people. Most folks are going to have 1 or 2 databases and 1 or 2 shard spaces, maybe 3. So it shouldn't be too bad. And also, this is a nice way of spacing out the load on the system. It's going to export a data definition languages for all the databases and the retention policies, and the data markup for all the data. So we're going to be able to recreate the databases and the retention policies for you. You'll notice that one of the things it doesn't export is it doesn't export the CQs, and it doesn't export users. Those will need to be explicitly recreated on the new 0.13 instance. There are different reasons for that. One, for the users, we cannot recover the password, and the user model has changed enough that it would be a little bit difficult to migrate forward. For the CQs, because the query language has changed so dramatically, there is essentially no way for us to reverse engineer a CQ from 08 format into 013 format. Or more to the point, we could try and we'd get it right about 1 in 5 times, which makes it not worth automating. So export results, they can be compressed. So when you're doing this export, it is going to spit out a file that is the line protocol representation, which line protocol is the right protocol for 0.9 plus. It's the line protocol representation of every point from that database and shard space in the 0.8 instance. So obviously that can be a lot of data. And since we are now storing it as a text, a line of text, there will be a lot of repetition of data. We're going to be repeating the measurement name, things like that quite a bit. So this is going to take up a lot of space. We definitely recommend using the compression unless speed is of the essence. Obviously, compression introduces both export and import load. It takes a little bit more CPU time. So you can do it without the compression, but if you're going to do that, you're going to need, I would recommend having at least 10x the space, just in case you have files that or data that explodes out significantly. And we give an example of the command below. So curl, we're going to say we're going to curl the endpoint. We're going to store the output in a file called export.gz. It is the gzip compression, and that's going to be compressed because we're giving it the compressed flag. And then we're going to give the URL to the database. I have u:"p" there in case you need to authenticate to your ODOT instance. So that's user:"password at localhost, or you can obviously replace that with the proper domain if you're not running this from a local machine. And then again, there's the export endpoint, and we're calling that with the database and then the shard space as the subdirectories or the subquery there. And that is then going to store all of the points from the given database and shard space in a file called export.gz. And again, repeat for every database and shard space that you want to export. So now we're going to launch 0.13 on a different server while those exports are taking place and while we're building these gigantic files. Download the InfluxDB package, launch the process, configure it however you want. Obviously, you've done the reading. You understand how to use ODOT13 now. You know what you want to do with those settings. So now we're ready to import the data. So after all of our exports have happened, and again, the export process may take a while. It is quite literally querying the database for every point. So that is, if you have billions of points, that is going to take some time, as in that is going to take many hours, possibly days, depending on your server. However, there's no reason we can't import the data incrementally. So as one database and shard space is fully exported, you can begin importing that while you're exporting a different database and shard space on the 08 server. We're going to use the command line interface that ships with every 09 plus. In this case, it's certainly going to have shipped with the ODOT13 installation that we set up. And it has an import flag that we can pass to it. And that import flag is specifically built to import those DDL and DML files that we're creating with the export endpoint. The way that it will work is that during the export process, InfluxDB attempts to take the measurement name from Influx08, which is typically going to be something like key.value.key.value.key.value.name space and then value equals. So what that turns out to be is key.value is really the tag key and the tag value. We'll attempt to break those down. The last thing in there, the name, is typically what we would call a measurement, the measurement name in 0.13. And then the value equals, the metric being recorded, is going to be a field named value in InfluxDB 0.13. So the exporter is going to make a best effort guess to fit your 08 schema into that sort of plan, to find the dotted pairs that form key value pairs, to figure out which is the sort of hanging or standalone thing that's the measurement name, and then take the field and which is probably called value and import that over there. But the field is the easy part. The metadata is the tough part. There will be times, most likely, if you have a non-trivial database, there will be times when the export tool is unable to guess what are the key value pairs and what is the measurement name. And so it will be unable to create the line protocol that might be best. It's going to be a good idea to go through and look at those files potentially to massage them before doing the import. However, it's probably impractical to read every line. So when you do the import, using this command below, influx, and again, influx, no D, influx is the CLI binary. We're going to call it in standalone mode here. We're going to give it the import flag. We're going to give it a path to the file that we exported. Since that file was compressed, we're going to give it the compressed flag. And then we're going to redirect output to failures.txt. And what that's going to do is any point that fails to import will end up in that failures.txt file. And then we can go back later, and that will be a much smaller list to parse, and we can look at that and figure out why did it not import. Was it because we were unable to determine what the measurement name was? Was it because there's a type mismatch? The most common reason that I think that points fail to import is a type mismatch. So, it could be that the first point in the series looked like an integer to influx13, and so it made it an integer field. And then the following points come in and are actually floats, and it won't store mixed type. The other possibility is that the points, the export tool took a guess at the schema and got it wrong, And so then the points that are attempting to write are invalid syntactically for ODOT 13. And this is one of those parts where there's just a wealth of complexity to why the points fail to import, right? We cannot predict what your O8 schema was or what it was intended to do. Only you can know for a fact what the data should be, and then and convert that into the proper format. If you run into some problems with import here and can't figure out what's going on, again, contact at influxdb.com, and perhaps there's a way that we can get some professional services to move you forward on this. The import process is relatively quick. It's basically the same speed as writing to InfluxDB ODOT 13. So again, it will be on a reasonable server. Let's assume you have, say, 4 cores and 16 gig of RAM. You're probably going to get something like in a few 100,000 to many 100,000 points per second that you're importing. And again, run some tests to figure out what that's going to be like, so that you can predict how long it will take for you to import all of your exports. And you'll need to build in some time to deal with whatever failed points are there. So once we've got our data imported, now we have to go around and figure out how to get all of our clients and all of our query sources, all the clients that write to Influx and all the sources that query it, to update it to the ODOT 13. Because we have all of our data in ODOT 13 now, but the things that write to Influx and the things that read from Influx don't know how to talk to ODOT 13. Again, there are major breaking API and schema changes. This is not something to just try. Oops, apologies for the popping out there. Where did Keynote go? There we go. So we don't want to, this is not a good time to wing it and just assume that you'll fix it in production and figure it out. You want to do your research. Here's a link to each of the pages that talks about the differences between the point releases. So if you read the 08 versus 010, that will let you understand what is the difference between 08 and 010, and then 010, 11, 11 versus 12, 12 versus 13. Incrementally, you'll begin to understand each of the changes in the database. Some of them will get negated. So some of the changes between 08 and 010 become irrelevant by the time you get to 13. But reading through each of these pages will give you a very good idea of what it's going to take to update your write clients and your query sources. There are libraries for most languages for ODOT 13, so it should be relatively easy to update your instrumented code. There are packages for Telegraph for reading data and injecting it into InfluxDB ODOT 13 from many different sources. So there's a strong possibility you can replace some custom code with an with a Telegraph plugin. And your query sources, if you're using something like Grafana, it certainly can talk to both 08 and ODOT 13, but you'll need to go into the dashboard and tell it, hey, I've changed my data source. This is no longer an 08, it's an ODOT 13. If you're using something else for graphing, then you'll need to update whatever tool or code that is in order to do the proper query syntax for ODOT 13. And then the final one is that we need to update the continuous queries. And there are a couple of changes here from ODOT 8. So again, first off, you're going to need to update the syntax just so that it's doing the right thing and working with the new schema. In ODOT 8, when a continuous query was created, it would automatically go back from the beginning and backfill that data from the beginning of time. So if we made a CQ that was going to downsample, for one day downsampling, and we make it 30 days into our database, it's going to go back over and do the previous 29 days as well. Starting with ODOT 9, that is no longer the case. Continuous queries only operate on fresh data, newly arriving data. And this is based on the timestamp of the data, not the time at which it arrives. If a point arrives today, but its timestamp is 3 weeks ago, my continuous query does not care. If a point arrives today and its timestamp is now, the continuous query will be picking up that data. Continuous queries are essentially just automated queries that run over the previous few intervals. So what does that mean? That means if I create a continuous query in ODOT 13 and I needed to downsample some data that hasn't already been downsampled or wasn't able to convert properly, or for whatever reason I need to backfill as if that CQ had been running since the beginning of time, there is an into clause that can be used with select queries, which essentially allows you to issue an ad hoc query that will do the downsampling and save the data where you want. There are good directions on how to do this. Again, there's the downsampling and retention link at the bottom of this page here. That guide will give you a lot of the context for how to build your CQs and how to interact with the retention policies in ODOT 13. Backfilling queries is an expensive operation. Be careful, limited in time. Do not try to do something like do it over all of time right now. That query may take hours to complete. It may burn up all the RAM on the box. Instead, do it a week at a time, a day at a time. You know, I would say a few million to a few tens of millions of points at a time is a great metric to use. And obviously, as you're doing this, you'll begin to understand the performance characteristics of your new ODOT 13 server, and you can regulate those queries to be whatever you need. Fan-out queries, which were a popular thing for CQs in ODOT 8, have no meaning in ODOT 13. The data is already essentially fully fanned out when it's written. That is one of the fundamental changes to the way the schema is. So there's no longer such a thing, and there's no reason to convert those forward. As we mentioned, shard spaces become retention policies. They have almost the same concept. The difference being that shard spaces, points that belong to a shard space were determined by a regular expression matching against the measurement. With retention policies, you are always writing explicitly to a particular retention policy. If you do not supply a retention policy explicitly on the right, then it will go to what is set as the default retention policy for that database, and there must always be one. But in terms of duration and expiration of data, shard space and retention policies work essentially the same. And then, as I mentioned with some of the others and at the beginning of the talk, the CQ scheduling is different in ODOT 13, and it is set per query. It's a relatively intuitive syntax language, and I think it should be pretty easy to understand. You'll see more about it on that downsampling and retention page. And now that we've fixed our write sources and fixed our query sources and exported all of our data from ODOT and imported it all into ODOT 13, and we've fixed all of our failed points, we are ready to start the traffic back against ODOT 13. Watch the logs for errors, and then, as I said, start slow to make sure that performance can keep up. Now, ODOT 13 is more performant than ODOT 8 for 95% of use cases. I don't have a good way of predicting whether or not you fall into that 5%. So start a little bit slow just to make sure you're going to be okay. If you've right-sized the hardware for ODOT 13, you should be all right. But again, we don't want to assume naively that it can immediately handle all that traffic. Even if the database is fine, there may be issues with the new code in your clients that are doing the writing or doing the reading, and those may need to be updated or tweaked for performance, or may need to be duplicated or sharded in some way. So hopefully that all goes well. You resume the traffic, everything's good, and now, again, you've gotten your data out of ODOT 8, which is end of life and no longer supported, and you've got it into ODOT 13, which will be much easier to move forward into the 1.0 and future lines, and will give you access to the rest of the tick stack. Things like telegraph and capacitor simply do not work with ODOT 8 at all. There is no version of telegraph or capacitor that you can run against an ODOT 8 database. So the other stuff, and this gets into what are the other things to think about when I'm going to be doing a migration like this. Controlling for performance changes is a big one, right? You definitely want to be running some tests in your staging environments in order to make sure that you understand how your performance requirements will change. Your CPU or RAM needs may go up or down. Your network needs probably will not change. ODOT 13, one of the nice things about the TSM engine is that whereas 0.8 and 0.9 would require somewhere in the tens of thousands of IOPS per second for great success, ODOT 13 with TSM is perfectly happy to run with 1,000 IOPS. So, you know, any SSD obviously meets that, and a pretty expensive NAS or SAN can do that. It is possible to run ODOT 13 on spinning platters with something like 180 or 200 IOPS. It will have significantly degraded performance characteristics. So anyway, performance changes are always something to look at when you're doing upgrades of this size. These are not trivial upgrades from the 0.8 or 0.9 line. If you're upgrading from 0.10 or 0.11 or 0.12 to 0.13, then you can assume the performance won't change dramatically. It should only get better unless there is some behavior in the database that has been changed that you were relying on that was perhaps an undocumented or a bug. But so control for performance changes. Another thing that can be a little bit of a gotcha when we're doing this is the file system owners and permissions. One of the things I did when doing my TSM conversions was I didn't pay any attention to the fact that I was logged in as root. I was just doing it on a dev box. I don't really use anything like sudo there. I'm always root. And when I did my TSM conversion and wrote those files back, they were now owned by root instead of InfluxDB. And that did cause some problems when I tried to launch down the line. So make sure that you preserve the file system owners and permissions when you do these conversions. Make sure that you're not introducing a lot of new users under the data path. Make sure that it's still going to be InfluxDB owner and group. Field type mismatch can be a problem when doing this as well. ODOT 8 was a lot less, it was a lot lazier about field types. ODOT 9 was relatively strict, but ODOT 13 has introduced even a little bit more stringency. So now it is possible to get into an integer versus float conflict. It is even technically possible to get into a Boolean versus string conflict if the strings are not properly quoted. A string that simply starts with a T will often get evaluated as a Boolean. So make sure that you're not going to run into issues there. If you do start running into field type issues, then the best fix is, if it's an 08 upgrade, you need to go modify the exported files to make sure that you're using the right field types on the right. If it's an 09 and up upgrade, you shouldn't run into this because you're converting the shards in bulk. So we're not actually rewriting any data. The fields don't get a chance to change per shard. With an 08 upgrade, one of the challenges as well, migrating the 08 queries where a column is both a tag and a field. So in 09 plus, tags and fields are mutually exclusive. You can have a field called value, but then you could not have a tag called value. You can group by tags and you can do functions on fields. You cannot group by fields. You cannot do functions on tags. So there are some 08 schemas which lead to a bit of a conundrum as to how to move forward. The solution to that is not often obvious. Again, reach out to us at contact@influxdb.com for some professional services help if you run into that. And with 08, fixing the failed points is obviously a challenge. And then controlling series cardinality. So series cardinality is an issue right now. It will be something we're addressing later in the year. But for right now, we need to keep the total number of unique series under. It's best to be under 1 million. It's almost required that you be under 10 million. Anything beyond that is going to require astronomical amounts of RAM and probably not be very performant. So you can read more about the series cardinality on the link given there. And again, this is one of those things where it may be a factor in your upgrade. If it is, there's no simple, quick, here's what you do about it answer. There's just a conversation to be had around that potentially. So with that, we come to question time.